Testing, testing, testing. Hi there guys, my name is Rohan Beve, and in today's video we are going to be talking about creep. What is creep and what does it do and well, why is it important? What is creep? Well, you see, creep is the process of which, basically what creep is it is the slow, permanent deformation of a material under a constant load over a period of time. And again, creep can happen especially on higher temperatures as well. So creep is the slow, permanent deformation of a material under a constant load over a period of time. And it's a bit different from, regular deformation. Unlike regular deformation where it just happens instantly, okay, creep happens over a long time, a period of long time, okay? So how does creep work? Well, it all begins in the metal itself. You see, inside the metal, okay, are tiny crystals, okay, which are called grains, okay? And you see, the higher the temperature, okay, the grains slowly start to move because, that in higher temperatures, right, the atoms start to move faster and faster. So the atoms shift ever so slightly and shift positions. The grain boundaries start to slide, and the metal slowly changes shape permanently, okay? It starts to deform slowly over time, okay? And you see, there are more or less three stages of creep, okay? The first stage is primary creep. Now, you see, primary creep starts quickly, okay? It starts very quickly, and the creep rate gradually slows down, okay? And the material starts to adjust to, the load, okay? Because, again, creep only happens when the material is under constant load, okay? Even if the load's weight never changes, okay, over that period, if it never changes, it can still happen. So in the first stage, primary creep, it starts quickly, but the creep rate gradually slows and the material adjusts to the load. Then it reaches the second state called secondary creep, okay? During this state, okay, which this state is the longest stage, okay, the deformation continues at a constant rate, okay? And by then, in this stage, engineers more or less use this stage to estimate the lifespan of the material, or just how useful can this material be for any much longer, okay? So this stage is the longest stage. Deformation continues at a rapid pace. No, not a rapid, but a constant rate. And engineers use this stage to estimate the lifespan of the material. And eventually it reaches the third stage. I can't spell out what the third stage name is, but when it reaches the third stage, okay, the damage eventually accumulates rapidly, and tiny cracks and internal voids start to form inside the material. The material starts to stretch until it eventually fails and breaks, okay? And that's more or less what creep is, okay? But why should we even care about creep? Well, you see, creep is especially important for high temperature and continuous load equipment. So equipment that has to go through high temperatures and continuous load. For example, like the fans or materials or just anything inside of like a jet turbine, right? It's under a constant load and it's super hot inside. And engineers have to constantly check the creep level of the materials, because if the creep rate gets too high and it gets to the final stage where it cracks or eventually fails, right? The entire engine can start breaking down because of a broken piece, okay? So that's why it's important, okay? So, how do engineers prevent creep from happening at all? Well, you see, some ways that engineers prevent creep include basically choosing creep-resistant materials, okay? And the materials have to be worked in, the temperature has to be worked in safe limits, okay? So the material is used in temperatures that are within safe limits, okay? And the material's design has to be better, thicker, and stronger for specific components, okay? And engineers should also regularly inspect the material just to make sure that there is no deformation. Well, that's basically what creep is, okay? And well, that's basically it. So, thank you guys so much for watching today's video, and hope to see you next time. Bye-bye.